Hello, as we discussed in the previous video about the optical fiber principle. Here, see here, this is the boundary line between the rarer and the denser medium. Here the denser is representing the refractive index n1, for example. Here it is the n2. Here the refractive index is nothing but generally n1 is greater than n2. Here the refractive index is nothing but light velocity in air by light velocity in medium. For example, refractive index is 1.5. Obviously, air velocity is 3 into 10 power 8 by medium, C medium. Then C medium is nothing but 3 into 10 power 8 by 1.5, which is equivalent to 2 into 10 power 8. That means that if the refractive index value is increases, light velocity is decreases. Similarly, in case of denser medium, the velocity of the light is less, and in case of rarer, the velocity of the light is more. So the ray starts from the denser, this is the direction, and is the angle of incidence. Once it reaches to the rarer, it away from the normal. It is not moving in the original direction, it is away from the normal because its velocity is more, and this angle is refracted angle, then I is less than angle R. In this case, if I increase the angle of incidence, then obviously further it enhances. This is the first case, this is the second case. This is the first case and the second case. Again it increases. Once it reaches to a particular angle, this is the third case for example. Once it reaches to a particular angle, which is take it as the critical angle, the ray travels along the boundary between the denser and the rarer medium. What happened if the angle of incidence is more than that? Case number 4. Then obviously ray get into the same medium, which is called as total internal reflection. So here the condition we should consider, first one, ray should start from denser to rarer, and second one, angle of incidence either equal to the critical angle. If it is equal, the ray travel along the boundary, or if it is greater than the critical angle, then ray get into the total internal reflection. This is the principle involved in the construction of total internal reflection. The same is used in making the optical fiber. For example, in case of optical fiber construction, I just taken the concentric circular tubes, cylindrical tubes. Here this is the first part, and this covered with the second part. Just assume both are concentric coaxial cables. This is the first part. Right? So obviously the central part is take it as the core, name it as core, and second part is take it as the cladding. Here it is a refractive index is n1, here the refractive index is n2. Here which one should be considered? Either n1 is greater than n2 or n2 is greater than n1. Here the ray need to get into the total internal reflection within the core part, that is within the denser region. So n1 is greater than n2. So light, for example, this is the axis. Light starts from the media, air media, and this is the normal. It making angle, some angle, and the ray is traveling from the rarer to denser, then it deviates and it is towards the normal. It won't move like this, it towards the normal. Here, if you able to make the angle of incidence either equal or greater than critical angle, it get into the total internal reflection. So this is the principle involved in the construction of optical fiber. Here what we need to take the precaution, this one, n1 should be greater than n1, and this angle should be tuned to match the condition of either critical angle equal or greater than. If it is equal, the ray is travel like this along the boundary between the core and cladding. If it is greater than the critical angle, the ray is get into the total internal reflection. Again, these are two or alternate angles. Again, total internal reflection possible. The similar way, the ray can travel from one end to the another end. So this angle is most important. That is, it called as incident angle at air core interface is one of the most important parameter to get the total or to propagate the rays through the optical fiber. Thank you.